I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on drawing velocity time graphs. Today we're going to learn how to draw velocity time graphs. These are very important in kinematics because they hold the answers to many questions just by drawing a graph. So it's important that you know how to draw a velocity time graph. So let's start first by looking at the types of motion: not moving, moving at a constant speed in the negative and positive direction, speeding up in the negative or positive direction, and slowing down in the negative positive direction. So just like in the position time graphs, we have 7 types of motion. So let's look at drawing a velocity time graph. So for an object that is not moving, what does it mean if it's not moving? Well, its position isn't changing. Most likely you're watching this video and your position is not changing. So we're going to draw a velocity graph on the axis, which means it has a 0 velocity. It's a horizontal line on the axis, and that represents a 0 velocity. So how would we draw it for constant speed? So let's say we have an object that's moving in the positive direction at a constant speed. Well, constant speed means it's a horizontal line. Positive direction means that it is drawn above the time axis. So it is important to understand that where a velocity time graph is drawn shows the direction. So when it's drawn above, that means it's moving in the positive direction above the time axis. Horizontal line shows that the speed is constant. So what about an object that is moving in the negative direction at a constant speed? So again, remember, direction means that the object's velocity is negative, so it's drawn below the time axis, and it is drawn in such a way so that the speed doesn't change. It has to be a horizontal line. So a horizontal line drawn below the time axis shows a constant speed in the negative direction, or a constant negative velocity. So what does this look like for an object that's speeding up? So an object that moves in the positive direction and speeds up, we'd have a graph that looks like this. It doesn't necessarily have to start from 0, but in this case I have the graph starting from 0. This shows that the speed is increasing because the velocity time graph, that line is getting further from 0, so the speed is getting faster and faster as time goes on. And it's showing that it's moving in the positive direction, as we mentioned before, because it's drawn above the time axis. Above the time axis shows the direction of being positive. So what does that look like for something moving in the negative direction and speeding up? Well, again, we'll start the graph from 0, and we can see that the line is negatively sloped. And this shows that the speed is increasing because the line gets further and further away from 0, showing that the speed is increasing. So it's showing a negative direction, again, because it's drawn below the time axis. When an object's velocity is drawn below the time axis, that means that it is moving in the negative direction. So it's drawn on the negative side of the velocity. So this graph shows negative direction and speeding up because the line gets further from 0 and it is drawn below the time axis. So let's look at situations with the object slowing down. So in this case, we're going to look at the velocity of an object moving in the positive direction and slowing down. So we're going to have this line where we have a velocity that is not 0 to begin with, and it decreases to 0 over time. So because the line gets closer and closer to 0, that shows that the speed is decreasing. So the line gets closer to 0 from 6 meters per second to 0 over that 6-second interval. And again, it shows that it's moving in the positive direction. Why? Because it's drawn above the time axis. I cannot stress enough how important where it's drawn shows the direction. So let's look at an object slowing down in the negative direction. So this graph represents an object slowing down in the negative direction. So let's break it down like we have the previous ones. So the speed is decreasing. Why? Because the velocity is getting closer and closer to 0. That means the speed is decreasing. Even though it's going from negative to 0, it's still a decreasing speed value. And it's drawn below the time axis, which shows the negative direction. So let's summarize our velocity time graphs. So horizontal line on 0 means that it's not moving, 0 velocity. Horizontal line above the time axis shows a constant speed in the positive direction. A horizontal line below the time axis shows a constant speed in the negative direction. A positively sloped line drawn above the time axis shows that it's speeding up by the velocity getting further from zero, and it shows positive direction by it being drawn above the time axis. A line drawn below the time axis and getting further from zeros shows the negative direction in speeding up. It shows speeding up because it's getting further from zero, and the negative direction because it's drawn below. When we have a line drawn like this, that shows that it is slowing down in the positive direction. The speed is getting closer to zero, positive direction because it's drawn above the time axis. And when we have a line drawn below the time axis approaching zero, this shows that it is slowing down in the negative direction. Again, slowing down because the velocity is getting closer to zero and because it's drawn in the negative side of the time axis. That shows slowing down in the negative direction. So let's combine these. So let's look at an object moving in the positive direction and speeding up. So we know from our experience, positive direction means it's drawn above the time axis. Speeding up means that it's going to start somewhere closer to zero and get further away from zero. So let's draw a line from 0 to 3 seconds, reaching a speed of 5 meters per second. Then we want it to speed up to a constant speed. Well, constant speed, we know the speed's not changing, so the velocity is constant. So we're going to draw this horizontal line, and this represents the object speeding up for the first 3 seconds, and then maintaining a constant speed for the last 3 seconds. So a combination of two types of motion. So let's look at a second one. An object moves in the negative direction and slows down. Well, negative direction, I know it has to be drawn below. Slowing down means it has to get closer to zero. So I'm going to draw it so that for the first 3 seconds, it starts at -5 and gets closer to zero. Yes, that means slowing down because it gets closer to zero, and it means negative direction because it's drawn below. So then we're going to show it speeding up in the negative direction. So still drawn below the time axis because it's the negative direction, and speeding up now because it's getting further and further from zero. All right, so let's look at a situation where the velocity graph crosses the time axis. What does it mean when the VT graph crosses the time axis? Let's break that down into what we know. So let's break it into pieces. What we know is that when an object is drawn with a velocity time graph below the time axis, that means it's traveling in the negative direction. And when it's drawn above the time axis, that means it's traveling in the positive direction. So what does it mean that's happening at that moment in time? Well, if it was negative before 3 seconds and positive after 3 seconds, that means that the object switches directions. So when it crosses the time axis, that means the object just switched directions. So let's think of a real world example that could have shown this. So let's say you have a lab cart in your physics classroom and you have an inclined ramp, and you roll that cart up the ramp and let it roll back down. Well, we assume up is negative, so it has an initial velocity of -5 meters per second. It slows down to a stop at 3 seconds, and then it turns around and speeds back up to that same 5 meters per second at the bottom. So when it crosses the time axis, all that means is that you just have the direction changing. The speed is zero for just a brief moment in time. So here is how you can draw different velocity time graphs based on the different graphs we've drawn. There's only 7 types of motion. I hope this was helpful. I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.